the angle we're going from. Always the angle or the reference angle. Okay? You're okay there. Now, because I know what the point is, this right here is negative 8/17, because you're over negative 8/17 and you're up 15/17. You're okay there. How do I find the third leg of that triangle? Good old Pythagorean theorem, right? Okay, so I go, okay, negative 8/17 squared is 64 over 289. That basically means just squaring top and bottom. Plus 225 over 289. That's 15 squared over 17 squared. Are you okay there? Doesn't equal that 3 squared, and you're at 289 over 289, which is 1 equals 3 squared over c is 9. Okay, so now you got your whole triangle, right? And remember, you're standing here and you say, oh, sine of that angle is opposite. So 15 over 17 over, yeah, that's 15 over 17. So therefore, I know the secant, because they're asking all six, aren't they, would be what? 17 over 50. Does that make sense? Then the cosine of that angle is negative 8/17 over 1, which is negative 8/17. Therefore, that means the secant is 17, negative 17 over 8. Get the idea where we're going there? And then tangent operating this one again. That's the y value, which was negative 17, or excuse me, 15/17 positive over negative 8/17. Notice whenever we have a fraction over fraction, we times the bottom by, the top by the bottom for reciprocal. So, we times by 17 over negative 8 for tangent, so that's why it would be negative 15/8. Okay? And then what would be cotangent then? Negative 8/15. Does that make sense how you would go about that? Anybody have a question? Remember, we also discussed, if it was on the unit circle, it's the x value and the y value. Remember, sine is the y value, cosine is the x value, tangent is y over x. And notice this is on the unit circle. How do I know this point is on the unit circle? My radius is... Does that make sense to you? How about your last Chris? Anybody have a question? Okay. Let's go more into, and here we go. So, if you recall, can anybody tell me, here's my 45, 45, 90-degree triangle. I call this guy x here. What's this side here? This guy would also be x because it's an isosceles triangle. They have to be the same. And then remember, I proved using Pythagorean theorem that this guy was x root 2. Is everybody okay with that? Remembering that. Okay. And then we had our 30, 60, 90 triangle, correct? So this guy, we'll call him up here 30, this guy 60. This guy was 2x, this guy was x, this guy was x root 3. And we proved that using an equilateral triangle, using the angle bisector, and then doing Pythagorean theorem to find the third side, if you'll recall. Anybody have a question so far? Now, in today's lesson, this is what they will show you. Okay? What they are doing is using your special triangles, such as this. If I said, okay, this guys are congruent, what triangle is that? 45, 45, 90, because if it's a right triangle, okay, we already have 90 degrees taken care of our 180, right? And the other two are the same, so I take the rest of it, 90 degrees, and divide it by how much? The 2, and hence, that's where the 45 comes from. Is everybody okay with that, moving that picture? Okay, let's pretend, though, or let's just say the hypotenuse of this 45, 45, 90-degree triangle is 20. I would like you to tell me the other two sides. Okay, how would I go about with this? I would go about by saying, okay, what does this 20 represent on my basic triangle? It equals the x root 2, huh? Does everybody see how he equals the x root 2? He's the hypotenuse. So therefore he equals the x root 2, doesn't he? Well, if I solve for x, I know what the sides are, because x are the sides, aren't they? So if I solve for x, I can find out the sides. So how do I solve for x? I don't want to square it, because if I square it, that gives me an x. I guess you could do that. But me personally, I would just go ahead and divide by root. I think that. I like it that way. So x equals 20 over root 2. Can anybody tell me what's wrong with that? We don't like a square root or a irrational number in our denominator, right? Okay, so we're going to rationalize our denominator by doing what? We're going to root 2 times root 2 top and bottom, which allows us to get rid of the rational number and irrational number on the bottom and make it a rational number being square root 2. Square root 2 is square root 4, which is 2. And what's square root 2 times 20? 20 root 2. Is that my answer? And what does 20 and 2 have in common? 2, so that is 10 root 2. So going back up to our triangle, I know this side is 10 root 2 as is this side. Everybody understand that? What'd you say? It has a blue condensation paper. Okay. Now let's do a 30, 60, 90 triangle, okay? 30, 60, 90 triangle. So with that being said, our 30, 60, 90 triangle, okay, where this guy is 30, this guy is 60, and this guy is 3. I want you to tell me the rest of the triangle. So what side am I given? Am I given the x root 3, or am I given the 2x of the ratio triangle? Am I given the x? No, I'm not. I'm given the x root 3. Can anybody tell me why I'm giving the x root 3? Because I flipped it around on you, didn't I? Notice, up here is 60 now, huh? That's what I did on this triangle. Right here is 30. Who is opposite of 30? The x. Opposite of 60 is the x root 3. So therefore, 3 equals x root 3. Right? Now what? Divide by root 3. So I have 3 over root 3 equals x. Rationalize. 3 root 3 over 3. X equals root 3. Everybody understand where I got that from? Exclude the x side. This guy is the x side. What's this side? 2 times the x value, and our x value is root 3, so this is root 3. Any questions on how you go ahead and use the ratio triangle of the 30, 60, 90 and the 45, 45, 90 triangle to find out the rest of the side? Basically what I say is, what side am I given? Am I given the x side? If it's the x side, your triangle is easy, right? You plug that into the other ratios of that triangle, correct? And do so forth. If I'm given the 2x side, well, I still got to solve for x, and after I find x, I can find the rest of the triangle by putting that x wherever it needs to be, correct? Does that make sense to everybody?
Wait, how did you get to root 3?
Okay, how I got to root 3 is, do we recall back up here? I was given this side right here. So then I found out what the x value was, which was root 2. Cut this root.
Oh.
And then this side is 2 times that x value, but our x value in that case is root 3, so 2 times root 3 is that x. Is everybody okay? 6. That's the coordinate root 3 over 2 comma half. That's what I do first. I figure out the coordinate. Then I say to myself, I am finding the sign, so therefore that is 1 half. That is what my brain does. Okay? I find the coordinate that associates with the pi 6. Then I say, okay, sine, that's the y value. Any questions on how I go about it? Okay, I correlate to what that angle is, and then come back, and then say sine. Just thought I'd ask, doesn't hurt. So, onward and upward. What they're going to ask you to do is something like this. They're going to give you a trig function. This is their trig function they're going to give you. This is your degree. This is your radian. And then this is your answer basically. So they're going to give you a chart like this, okay? So for example, they would say sine, we just did this one. We could do another one. What's another angle you guys want? Let's do 5 pi 6. How about that? Okay? So that's what they give you. Sine, and then they give you 5 pi 30. So what do you think they're asking for this right here? What angle corresponds with, or what degree measurement corresponds with 5 pi 30? 300. Okay? Once again, I hope that you can get to that as quick as well. 5 pi 30 is 300. Good. You know what I mean? We want that's kind of why I'm having you memorize this. And so that's why, once again, I reserve the right to do a unit belt width or unit circle belt width at any time during this time. Okay? Because I want enough to me that you guys are on top of it. You just didn't study once and let it go. You know what I mean? So I kind of want you to consistently always know what it is, so therefore that you're ready to take it. Okay. And then after that, it just says, okay, what is the sine of 305 pi thirds? Me personally, I'm looking, okay, 5 pi thirds. That would be 1 half comma negative root 3 over 2. That's the coordinate. That's what I do. I personally write the coordinate down. Okay? And then I say, oh, it's the y value, so therefore it is negative root 3 over 2. Does that make sense? Any questions there? Okay. They might say tangent of 90 degrees. What do we have to fill in on this one? Well, what's the radian conversion to 90 degrees? It would be the pi half. Right? And then we say, okay, well, the coordinate of pi half is 0, 1. That's what I personally do. Is I find out the coordinate, correct? And then I say to myself, okay, tangent is y over x. That would be 1 over 0, which is 9 to 1. Okay? Any questions there? What do you think the other way would be at? The last one, they could say maybe, okay, where is secant negative 2? Okay, you guys want to see how I process through this with my brain? This is what I do. Okay, so first off, I say to myself, well, secant is the same thing as 1 over cosine, right? Okay, does our brain think in 1 over cosine, or we usually think about cosine? Usually the cosine. So if I flip this, this is cosine. Well, because I flipped him, what do I have to do to this guy? I have to flip him, so basically I'm asking myself, where is cosine? Negative a half. You guys see how I went through that in the process of my brain? That was my brain. You guys might have to do other things. But that's what I did. I said, okay, secant is the same thing as 1 over cosine. Well, I don't want to deal with 1 over cosine. I don't want to deal with cosine. So I flipped it. Right? Well, if I flip him, what do I got to do to him? Flip him as well. Does that make sense? Then now I'm like, okay, where's cosine negative a half? Cosine is being the x value at negative a half. Well, actually I know there's 2 spots for that, isn't there? There's 2 spots where cosine is negative a half. It is at, if you recall, 120 degrees and 240 degrees. If you'd like to look at your unit circle, you can. Once again, hopefully try to pull away from that. This memorization helps. On your test, somebody asked me to look at, are you going to have to fill in the unit circle? Nope. Can I give you a unit circle for you to fill in? Sure. Okay? It'll be just like that. You'll steal another one if you want to, so that you can bring if you can use the unit circle if you do it all by yourself, because that's using your knowledge of the unit circle. Okay? Does that make sense? Okay. Well, who corresponds with 120 degrees? Well, we already know that. We're just looking for our radian right now. Sorry. 120 degrees is 2 pi thirds and 4 pi thirds. And I can do this one. If you find this one, it's easy to find because you just either double or cut in half. You know, one way or the other, right? Does everybody understand how we went ahead and found that? Looking at the thing that's given to me and then going and find the other information. You okay with that? Okay. Okay. Did I show you guys the other yesterday, or last time? Did I show you guys that tangent? All right, I know I talked about it today. That tangent of theta is the same thing as sine of theta, cosine of theta. Did we talk about that?
No.
Okay, so you might want to have one of those next to your identities. Okay, that sine over cosine is equal to tangent. Sine over cosine is tangent. That's a lovely little cheat sheet. Not a cheat, you get what I'm talking about. Maybe not the cheat stuff, but I know. I like that they're blue. What are your shoes? Are they suede? Then I thought you'd like that. Says tangent. What is cotangent? And you could use this at any time, and hence why, guys, you remember how we said tangent y over x? Well, what was sine? It was the y, right? So it was the x, cosine, so hence y over x. Helps you out a little bit more there. X over the y. Okay, any questions on that? Okay. Now, the next thing I'm going to ask you to do, what if I ask you to find the cosine of 5 degrees, 12 minutes, and 40 seconds? How do you find that value? Now, what does degrees, minutes, and seconds mean? It's a more precise angle measurement. That's what it is. Is everything exactly 44 degrees? It's not usually right on, is it? Okay, and instead of saying 44.8927, okay, they do it in degrees and minutes. Okay, degrees, minutes, and seconds. Well, we already know how many seconds are in a minute. 60, right? So how can I convert that 40 into minutes? Well, you just divide it by 60, right? Okay, so that's 12 plus 60, so that's 12 plus 2/3, basically. So that's 12.666 forever. Correct? Is everybody okay there? Yes or no? No problem. So I know there are 60 seconds in a minute, correct? So I divided the 40 by 60. 40 divided by 60, that's 60. Or this 2/3. Because I'm going to try to I'm going to show you how to put it in your calculator. Okay, so I got to use this. There is a way to use this, but there's actually, I can't find any seconds in my calculator. I know how to deal with degrees and so forth, but I'm going to show you how to do it. So it's 12.66, but now this is minutes, right? Is everybody there? So now I'm at cosine of 5 degrees, 12.666 minutes. Okay? So how do I get this guy back into degrees? What am I going to divide him by? I'm going to divide him by 60 as well. Because there is 60 minutes in a degree. Okay? Or like a degree as an hour. Sorry, bud. Wikipedia got saved it alive and then it's on the internet. Yeah. Got it. So now this is 5 plus 12.666 you how I'm going to do this on my calculator, okay? Here we go. So I get my rabbit out here. Let's turn it on. What was it at the beginning? 5, 12, 40? Is that what it was? Yes. Okay. So what I do first, okay, is I go, okay, my 40 divided by 60. Okay, that's my fraction. That's how many minutes that is. So I'm going to add it to our minutes that we already have. So now that tells me how many minutes I'm at. 5.6, or excuse me, it should be 12.67, right? It wasn't 512. Sorry about that. I'm going to add 7 more. The only reason is because it was 12 minutes and not 5. Okay? Now what do I need to do to this guy? I need to divide him also by 60. And now this tells me how much is this in terms of degrees? Well, it's 0.21111 degrees. Okay, but how many degrees do I already have? 5, so I add that to it. 5.211 blah, 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 blah. Okay? Now I want to find, what did I want to find? The cosine of that? So I hit now cosine of that answer. And first off, I need to read what note, sorry. Degree, no it's not. So now I do that again. Shoot. Oh, that's right. I should do so. Oh, I didn't know I had the up arrow capability. So 0.9995. Should we do it all over? Let's start again. Just to make sure. So I had 40 minutes, correct? 40 seconds. So I go 40 divided by 60. Now it takes those seconds, and this is how many minutes those seconds were. 2/3 of a second, right? So I add my seconds to that. That tells me how many minutes I have. Well, I don't want to be minutes, I want to be in degrees, so I divide that guy by 60. How many degrees do I have? 5, so I add 5. And then I go, okay, I'm taking the cosine of that answer.
Yeah, how do you do it?
See the answer button A and F here? So I hit the blue button for me and the negative button. You see that? You okay with that?
Yeah.
Yeah, because it's the decimal at and obviously I can't hit that without, if I stop it, that's not the same thing anymore, is it? I guess you're right. Degree. Let me show you another way to do it. Okay, here we go. So I'm going to hit cosine 5. You guys see right above x, it says angle. So I go angle, degree, 12.6666666. Half, minute, notice there's no seconds there. Close your parentheses. Same answer, right? Okay, so just to know how to use that, that's basically what it's doing. Okay. Do you have a question on those? Huh? My shirt is a nice shirt, huh? That's my wife. Oh! I just thought of that. Now, gotta figure it out, and the only way to figure that out is either throw a measuring tape across, and hopefully that works. Or, back in the day, maybe they didn't have measuring tapes, okay? You paste the river? Tape. Oh. That's what we're doing. We're pasting the river here. Okay, we're going to paste this direction, and then we have the tool. You say, guess what? This angle right here is 12 degrees. Kevin, shut up.
That's a really big boat.
This is, let's say, 70 feet. How far is it across the river? You guys are a bunch of lazy bums. If I'm standing here, which trig function am I going to do? This side represents opposite. This represents adjacent. Who's opposite adjacent? Who's tripping on apples? Tangent is. Hippies are actually. Tangent of 12 degrees. So what mode should my calculator be in? Degree mode equals x over 70, right? How do we solve this? We times 70 over, so x equals 70 tangent of 12. Recording again, thank you. Here is our mountain. We drive 6 miles in, you take this, we're solving, put them in trig function, solve for h, we're here, thank you. Okay, so, nobody reminded me. Okay, so now what you want to do is I want to get this stuff to the other side. So I'm going to times by x plus 6. So now I have x plus 6 times the tangent of 5. Does everybody know that the tangent of 5 is just a number? So it's like saying x plus 6 times by 3, basically, right? Right now. Isn't that basically the same thing, except we just don't know what the tangent of 5 is? Do I want you to put that in your calculator to think what that is? No, I don't. Not yet. Okay? You're there with me. Okay, onward. Now I'm going to distribute that through. So I have, notice, x. I'll move that up. Tangent of 5 plus 6 tangent of 5 equals x tangent of 15. Everybody understand how I'm to there? Mike, you good? Yeah. Now, notice, ladies and gentlemen, if this was 2x plus 7 equals x, what would you do? You'd get everything with an x on one side, wouldn't you? Same idea. I'm going to go ahead and subtract x tangent of 5. Are they alike? Can I add those together? Tangent of 5 and tangent of 15, you can't add those together. So I am here. 6 tangent of 5 equals x tangent of 15 minus x tangent of 5. What do those guys both have in common, and don't tell me tangent? They have an x. So I pull out the x. And I'm factoring out the x. So now, this equals the 6 tangent of 5. Isn't this x times that now? How do we get rid of the times? The 5. Now you might be saying, holy Christ, yes, this is going to be somewhat important for you to know. X equals 6 tangent of 5 over tangent of what was the first key? Dang it. I thought I had time. Tangent of 5. We go to our machine and we plug that in. Okay? Is that what I wanted to know? Did I want to know what the x value was? I want to know the height. So after I find that x, I times it by the tangent of 15. That will then tell me my height in terms of miles. Because that x is in terms of miles right now. If you'd like to stick around, I can show you. I've been hurrying writing your homework down. Okay. we go. Homework is 1 through 15 odd, 17 through 26 odd, 27 through 31 odd, I'm almost there, 43 through 61 odd, and then 65 and 68. Okay, this is on 4-3. I will finish this problem if you